All right, so let's use the pattern here that you see, 6, 13, 20, 27, and try to figure out the next two terms in a sequence. Well, 6 plus 7, then plus 7, then plus 7. So this is arithmetic, where the common difference is 7. So every time you're adding 7 more. So the next two terms, well, 27 plus 7 would be 34. 34 plus 7 is 41. Now what about the 15th term? So recall that the general term of an arithmetic sequence is in the form of a plus d, a plus 2d, a plus 3d. So the 15th term, so this is the first term. Write that again. So the first term is basically a. Second term is a plus 1 plus a d. The third term is a plus 2d. Fourth term would be a plus 3d. So the number of d's you're adding to it is one less than the term. So the 15th term is basically what you started with plus 14d. So I started with 6. I want to go 14 times my difference of 7. So 6 plus 98 comes out to be 104. Well, this one, how many numbers are in this collection? So 1, 4, 7, 10, 13. So this is arithmetic, where I started with 1 and I'm adding 3 each time. So what I want is my the number of terms. So the nth term would be a plus n minus 1 times d. And I want that equal to 682. So 1 plus n minus 1 times 3 equals 682. Subtract 1. So n minus 1 is times 3 is equal to 681. Divide by 3. So 681 divided by 3 would be 2. And then 2, 7. So 227. So my nth term would be 228 if I add 1. So there are 228 numbers in this collection. And for this one, see if we can figure out a pattern. I know 1 times 1089 is 1089. 2 times 1089 is 2178. Then 3267, 4556. If you notice that this pattern 1, 2, 3, 4, it looks like the digit on the left would be 5, 6, 7, 8, 9. And then the hundredths place 0, 1, 2, 3. So the pattern 4, 5, 6, 7, 8. And then 8, 7, 6, 5. Then 4, 3, 2, 1, 0. And then 9, 8, 7, 6. 5, 4, 3, 2, 1. Well, let's see. You check a couple of them. So if I go 1089 times 5, that's 5,445. From there, let's try adding. If I add another 1089, that puts me at 6,534, then 7,623, then 8,712, 9,801. So the pattern does work. Let's try a visual pattern. So we have 1 dot, then 3 dots, then 5 dots, and 7 dots. Looks like the next one would be 1 with 8 dots after that. So I went from 1, 3, 5, 7, 9 dots. So this is an arithmetic sequence shown visually, geometrically. How many dots would be in the hundredth figure? Well, A is 1, and then my common difference is I'm adding 2 more each time. So if I go 1 plus 99 times 2, that would be 199 dots. Okay. And one more. 1, 3, 6, 10. These are what are known as triangular numbers. And I'd add 2, then add 3, then add 4, and so on. What is the 100th triangular number? Well, that would be what happens when you add the numbers 1, 2, 3, all the way up to, let's see, the first number you have 1 dot. The second number is 1 plus 2. The third number has 1 plus 2 plus 3. And the fourth number has 1 plus 2 plus 3 plus 4. So the 100th number will go up to 100. All right, so how do we add that? Well, we can we write it 1 through 100. Then let's write it again on down to 1. Add these column-wise, 101 plus 101 plus 101. So what we have here is that's 100 of these 100 ones. But we did 2 sequences, so divide by 2, that comes out to be 5,050. So the 100th triangular number is 5,050.